To describe the general integration, we open the help file delivered with the ESX-3xx target support package. Under Matlab Simulink data pool, we find a block diagram of the integration. Left, there is the ECU or embedded side, and on the right there is the PC side and the development environment. The data pool is a central repository for all variables which are globally available on the ECU. It contains application variables, hardware IOs, as well as parameter values. It is the central interface between the generated code from Matlab Simulink and the existing application code. The content of the data pool is defined via the STW program RamView. Within RamView, data pool constant tables for ECU side and a DPM file for use in Matlab Simulink can be generated. DPM is short for Data Pool Matlab. To show the workflow, we will look at the PVM example, which is also part of the target support package. First, we open the example within Matlab Simulink. The example has an initialization block. Code from this block is called in the startup phase of the controller. There is one cyclic task with an hour meter. On the right side, we have a termination block. This block is called just before shutdown of the controller. In this example, it is used to save the working hours calculated in task 1 to the EEPROM of the controller. Finally, we have a second cyclic task for all other jobs. In this task, we work with the multifunction inputs 1 to 5 and several outputs of the ESX-3xx. We will look at multifunction input 1 and output 1. To do that, let's look into the subsystem. Here we see the logic combination. Input 1 is an analog voltage input. This input is multiplied with an EEPROM parameter, MFI1P, and the product of the input and the parameter will be given to the PVM output OUT1. Now we will look into the data pool of this example within RamView. First, I open RamView and select the project DP-AIN PVM out. RamView organizes the data pool with the help of different lists. Generally, the lists are separated into RAM lists for variable and hardware IOs, and parameter lists for parameters stored in EEPROM. Here we see the ECU IO list, which is a RAM list. The ECU IO list contains all inputs and outputs of the ESX-3xx mainboard. The multifunction input 1 and output 1 of our example can be found here. The parameter MFI-P of our example is in the parameter list application. RamView is used for defining the data pool, but it is also used to monitor and modify the values of the data pool at runtime. Each value within the data pool can be read and written if it was configured accordingly when creating the data pool. We can read a single value or the whole list. Different types of transmissions can be configured. If SRR is configured, the value will be read just once. If we change the entry to TCRR, then the chosen value will be sent with the defined interval. Here the value will be updated with an interval of 222 milliseconds until we press the stop button. A value can be added to a chart list to see the curves of the selected value. Next, we select the parameter list. We have the possibility to adjust parameters via RAM view. When we select this list, we see an additional tab EEPROM. When the tab RAM is selected, we have access to the RAM copy of the EEPROM value. When the EEPROM tab is selected, we have access to the EEPROM directly. A parameter value can be changed via double-click. With write changed, the new value is sent to the controller. Now the value is in the EEPROM of the controller, but is not yet used by the application. You see that the RAM value still has the value 1. To copy the EEPROM value into the RAM copy, which is then used by the application, we press the button Update Task. Now you see that the RAM copy is updated to 10. You can store parameters to file, load parameters from file, and compare stored parameter sets with the parameter set currently in use by the controller. Now we will look at how to edit the data pool. To edit the data pool, we have to enter the edit mode. In edit mode, we can modify all entries of the data pool. One important setting is the location. The location defines if there will be a RAM variable created for that entry. If the location is of type RAM, the value of the created global variable will be read or written. If a variable is of type function, a read-write access will result in a function call. Within this function call, for example, a BIOS function could be called for reading or writing of an output. This list is a list of the inputs and outputs, and therefore all entries are of location function. If we choose the list errors, the variable is of type RAM. That means there is a global variable with the name error EEPROM init. Now we want to export the data pool for the ECU. To do that, we go to Edit, Export, and choose Export C-Source for Simulink. Now the const tables for the C application will be stored in the defined C file. We want to use the data pool in Matlab Simulink as well, and therefore we export the DPM file. The chosen default values will be used for the simulation. Now we will look at the exported files. First, we open the exported C file for the ECU side. For each list that contains variables of type RAM, there will be a structure with the data pool members. Here we see the structure for the list application and the member MFI1P of our example. To access the entries within the C code, defines for list index and variable index are exported. Here we see the list index and the variable index of MFI1. Now we will check the Matlab Simulink side. First, we look into the DPM file. The DPM file is organized like an init file. In the DPM file, we find the list name, the variable name, and the name used within Matlab Simulink. The variable name will be created with the first 3 characters of the list and the entry name. Signal names start with RS. Parameters start with RP. When opening the model, the defined data pool will be automatically loaded. After opening the model, you see the available signals and variables of the data pool in the workspace. Here, again, we can find the multifunction input MFI1 of our example. We see also the list and variable index. These indices will be used during the code generating process. To summarize, we started with creation of the data pool. We exported the C structures for the ECU, and we get the variables in the Matlab workspace. Now we want to add and use a new parameter in our example. To do that, we have to extend the data pool. As described before, we do that with RamView. We go to the parameter list, Application, change to Edit mode, and append a new parameter. Here we call it test para. And the default value shall be 10. We won't add units in this case. Now we export the data pool for the ECU and for Matlab. The new parameter is now available in our model. We open the model and have a look in our workspace variables. We can do that by using the workspace browser, which is part of the target support package. We want to replace the old parameter of the example with our new parameter. The new parameter is at the very end of the list. We choose it and assign it to the selected block. When we look at the value of the parameter, we see that the defined default value of 10 is used. Now, we can verify the code via simulation. We start the simulation. The input value of input 1 is 1000. This value is multiplied with 10, and we get the expected result of 10,000. Now we want to test the code on the controller. To do this, we start the code generation. After successful code generation, the download tool WinFlash is started. We adjust the company ID and the bitrate and download the created hex file to the ECU. Then we start the program on the ESX-3xx. Now we want to verify that the code is executed as expected. We do that by checking the input and output values via RAM view. First, we check the value of our parameter. It equals the default value of 10. Now we check the inputs and outputs. The input value of input 1 is 258. This is multiplied by our parameter, and the output is 2580 as expected. If we adjust the parameter to 20, the output value is also doubled and is correct. Finally, we want to use a new input in our example. We want to use input 6 of the mainboard and send this value to output 13. To do that, we have to change the I/O configuration of the controller. This has to be done by adaptation of the ESX-3xl frame program. We open the frame program within code blocks. Within code blocks, we see the following directory structure. AIN PVM out RTW source contains the code created by Matlab Simulink. DP source contains the data pool. User source contains all the existing application code. The C file, hluser.c, contains the I/O configuration table for the mainboard. Here we can see that currently input 6 is configured as a frequency input. We want to use this input as a voltage input with 40 volt range. To do that, we adapt the table accordingly. Now we can change our model. First, we delete the old configuration of output 6. We add a new port. We want to multiply the value with a constant and send it to the output. We adapt the data types. The port has to be brought to the top level of the model. Then we connect the port with the input 6 using the workspace browser. Now we have to change out 6 to out 13. We activate the code generation. Download the created file. And check via RAM view. MFI6 has the value 40. Which will be passed to out 13. The code is functioning correctly.